This lesson is on the introduction to quadratic graphs. Quadratic graphs are going to form what we call a parabola, which is going to look like a U, whether it's up and down or upside down. So when we're looking at this, generally this means, well, always it means that your A is positive. This one means that our A is going to be a negative to make that reflection. So in this example here, I'm going to show you multiple ways to graph these. This particular one we're just going to do with a table. This is actually in what we call vertex form, which we're going to learn about in a couple days. But the idea is that you're going to be graphing it somewhere here on the x and y axis. So let's start with a table. We're going to call this x and f of x. And we're going to go ahead and start a table at 0. We're going to do 2 numbers to the left and 2 numbers to the right. I'm starting at 0 because right here x is squared. There's nothing inside this. Really, this is a transformation. It takes the parent graph where it goes through the origin, and it's going to go up 5 units. Vertex here is going to be at 0. Another way to know that is that when we deal with our vertex, it's going to be negative b over 2a. And so if you look, there is no b term, which means that we would assign that to be a 0, so negative 0 over 2a. Well, 0 divided by anything is 0. So that's the vertex. Now let's plug these other numbers in. If we put a negative 2 in there, we have negative 2 squared plus 5. Negative 2 times negative 2 is positive 4, and 4 plus 5 is 9. So this would be 9. Let's put a negative 1 in there. Negative 1 times negative 1 is 1, and then 1 plus 5 from this formula is going to be 6. Let's put the 0 in there. So 0 squared plus 5. 0 times itself is 0. 0 plus 5 is 5. Let's try the 1. 1 squared plus 5. So 1 times itself is 1 plus 5 is 6. And then we do the 2. 2 times itself is 4. When we add that 5, it gives us 9. See, when we find the vertex and we choose numbers that are equal increments away from the vertex, you should see that a pattern here. The vertex is the middle point here, and then after that everything's like a reflection in the y-axis. So let's go ahead and plot this. So I've got negative 2, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So negative 2, 9, negative 1, 6, then we have 0, 5, and then we got 1, 6. And I know this is not the best graph in the world, but then 2, 9 gives you that picture though at least. And when we connect this, it makes a parabola, a U. In this graph right here, this illustrates the need that we're going to need that negative b divided by 2a. And so what we're going to do is we're going to take the b here. We're going to say we've got negative 6 divided by 2 times that a, which is 1, which means our vertex is probably going to start at negative 3. So let's go to make our table for that and double check it. So this is x, and then this is f of x. Starting with x is negative 3, and then we want to go 2 numbers to the left and 2 numbers to the right with it. So we're going to go ahead and put it in this formula. So we have negative 5 squared plus 6 times negative 5 plus 8. Well, that would be 25 minus 30, which is negative 5. Negative 5 plus 8 would be 3. So plus 8 equals 3. Alright, then we do it with the negative 4. Negative 4 squared plus 6 times negative 4. Then we have plus 8. So negative 4 squared is 16. Then we have minus 24. Then we have plus 8. Well, we're going to get 0 here. And so on. So let me show you with the calculator what we can do. Another perspective that we can offer here. We can go ahead and put it in the long way. So we'd have negative 3 squared plus 6 times negative 3. Then we can add plus 8. And that gives me negative 1. If we want, we can go to putting this in y equals and using a table. We could say we've got x squared, so x squared plus 6x. Then we have plus 8. And then if you go to second graph, you can see that we can ask for some values in here. So negative 2, I got a 0. I could do negative 1, and I got a 3. Now I see the repetition here, but if I wanted just to make sure I did the correct math on all this, I can check any of the other ones. So there's -3 and -4, -5. Your calculator might be set up so that you can scan up and down. But what I notice here is that there's that vertex and then the mirror reflection again. So we're going to go ahead and create the graph. We got -1, 2, 3, 4, and 5. And then we really only need to go up to 3, down to -1. So at -5, we have a 3. -4, we have 0. At -3, we have -1. And then back up this way. So there's our parabola right there. The last type I want to show you is something we call vertex form. When we have vertex form, again, you can go ahead and first start off with the vertex. Well, you've got to think this is inside the parentheses, and so there's that inside opposite. So the transformation here will be 3 to the right. So inside opposite, 3 to the right. And this would just tell us it's going up 4. So that's our vertex. If we plug those in, we would get that middle of the graph. So we want 2 to the left and 2 to the right of this on the graph. So we can plug that in. Let's do this again with the graphing calculator. So you go to y equals. You're going to have to clear out what you put there. You want to use a parenthesis. X is right here. Then we would say -3, close your parenthesis. Then we're going to square it. Then we have +4. So now we go to second graph, which is the table function. And I'm going to go ahead and just plug these in. 1, 2, 3, 4, 5. And so what we see is that at 1 we have the number 8. At 2 we have the number 5. We already got 3. We got 5 and 8. So there's your mirror reflection. So now again we can just go ahead and plot the points here. So this is f of x. This is x. So then here we have 1, 8, 1, 2, 3, 4, 5, 6, 7, 8. And then we've got 2, 5, just here, 3, 4, and so on. I can tell I already graphed just one parabolas that are facing up, but if you have a negative in the front here, everything's just going to be a reflection and facing down.